Good morning, students. Once more, welcome to this YouTube class. I'm your host, Mr. Oyerinde, and Mr. Aderigbe is also here with us. And our topic today is Energy 2. I call it Energy 2 because we've already had Energy 1. And under Energy 1, we're able to define what energy is. I will say energy simply means the ability to do work. We also say that the unit of energy is joules, meaning energy is measured in a unit called joules. We are able to look at the law of conservation of energy, which states that energy can neither be created nor destroyed, but can be transformed from one form to another. And we also look at the various forms of energy transformation, how one form of energy can be transformed to other forms of energy. We also look at the Sankey diagrams that shows us what happens to our energy. So today we'll be looking at another form of energy, which is called Energy 2. And under this class, our objective is to describe various processes that lead to energy wastage. And I call it wasted energy. We're also meant to define fuel, state example of fuel, state uses of fuel, define fossil fuel, state differences or difference between renewable and non-renewable energy, and many more. I want you to pay close attention as we continue in our class today. Now, wasted energy. I'll quickly use an illustration. When you turn a lamp, it is because the light is useful to us. We do not use the heat that is produced, so it is wasted. So in the process of using our lamp, another form of energy is being created, which is heat energy, and it's a form of energy that we do not want, and it is called wasted energy. Sometimes that wasted energy can cause problems. For example, some machine makes so much noise that people using them have to wear air protection. So sometimes wasted energy could be of negative influence to us and the society. So this is a Sankey diagram that shows ways of representing useful and wasted energy. I want us to study it very well so that in our Zoom class we'll do further discussion on that. Now, examples of wasted energy. Let me give another illustration. When you buy a computer to make light on the screen and sound for music or other videos, so any energy going into the air or any sound energy from cooling fan is also wasted. Consider a computer when 150 joules of electrical energy. It produces 20 joules of heat as wasted energy. It also gives 10 joules of sound as also wasted energy. So the light can be useful energy. So what is a fuel? Fuel are substances that form to release their chemical energy to produce light and heat. Again, fuel are substances that are burned to release their chemical energy to provide light and heat. So whenever fuel is burned, it releases energy or chemical energy in them to provide heat and light. Examples of fuel are wood, coal, gas, diesel, oil, petrol, natural gas, and wax. These are the various examples of what we call fuel in physics. And what do we use this fuel for? We use it to warm our building, cook meal, make chemical in the industry, turn water into steam to generate electricity, expand gases in a vehicle engine. These are what we use. These and many more are what we use fuel for. Coal, gas, and oil were all formed from plants and animals that have lived millions of years ago. So they are known as fossil fuel. I repeat that again. Coal, gas, and oil were formed from plants and animals that lived millions of years ago, and they are known as fossil fuel. Now let's look at fossil fuel in details. And one of the fossil fuel that I want to consider now is coal. So let's look at the process involved in coal formation. Coal is formed from large plants that grew in swamp over 275 million years ago. Those plants use energy from the sunlight in the same way that plants do today. When they died, they fell into the swamp. There was lack of oxygen in the swamp water and prevent bacteria growing and decomposing the dead plant. Eventually, the plant formed peat. Later, the peat became buried and squashed by rock that formed above it. The increase in pressure squeezed out the water out of the pit and warmed it. This process slowly changed the pit into coal. So during the process of coal formation, peat is being transformed into or changed into coal. Fossil fuel, I've mentioned earlier. Fossil fuel now are example of non-renewable energy. Fossil fuel is fuel derived from hydrocarbon deposits such as coal, petroleum, natural gas, and to some extent peat. Those fuels are non-renewable and their burning generate greenhouse gases, carbon dioxide. Now, when non-renewable energy is being burned, they generate greenhouse gases as well as carbon dioxide or carbon dioxide, which is very dangerous for human health. Fossil fuels are formed from decay remains of plant and animal. So fossil fuels are formed from the decay of plant and animal. So let's look at renewable and non-renewable energy. A renewable source of energy is the one which is naturally replaced when it is used. The sun, wind, and water are sources of renewable energy. That is, they produce renewable energy. Non-renewable energy is the energy which cannot be replaced after use, but their stock is exhausted that cannot be renewed. I want us to go through this slide as many times as we can so that we can have a good understanding of renewable and non-renewable energy. We get energy from many different types of energy source, which include fuel, food, stores of energy such as battery or wind. We can divide energy resources into two categories. This is just repetition of what we have said before. Renewable energy sources that cannot be replaced as they are all used up, while renewable energy sources that can be replaced and will not run out. Now, examples of renewable energy source are your solar, wind, hydroelectricity, wave, and biomass. While examples of non-renewable are coal, oil, nuclear, minerals, propane, gasoline, and timber or wood. These are the examples of non-renewable sources. Now let's take them one by one. Biomass. What do you mean by biomass? Biomass fuel come from living things. Wood is a biomass fuel. As long as we continue to plant new trees to replace those cut down, we always have wood to burn, just as sweet with the fossil fuel. The energy stored in biomass fuel come originally from the sun. Another thing that we want to look at is wind power. Wind is caused by huge conventional current in the Earth's atmosphere, driven by heat energy from the sun. The moving air has huge amount of kinetic energy, and this can be transferred into electrical energy using wind turbines. Wind turbines cannot work if there is no wind, or if the wind speed is so high, it will damage them. So this is what a wind turbine is, which can be used to generate electricity. But if wind, it has a disadvantage, such that if there is no wind, it will not work properly. And again, if the wind is too much, it can damage the turbine. Solar cells. Solar cells are devices that convert light energy directly into electrical energy. So they collect energy from the sun and convert it into electrical energy. During the day, when the sun is very high, or when there is high illumination, the solar cell collects this light and turn it into electrical energy. You may have seen small solar cell on your calculator. Large array of solar cells are used to power road signs, and even large array are used to power satellites in orbit around the Earth. Solar panel. Solar panels are different to are different to solar cell. Solar panels do not generate electricity. Instead, they heat up water directly. A pump pushes cold water from a stored tank through the pipe in the solar panel. The water is heated by heat energy from the sun and returned to the tank. They are often located on the roof of the building, where they receive the most sunlight. These are the diagrams showing what a solar panel looks like. Water power. Moving water has kinetic energy. This can be transferred into useful energy in different ways. For example, wave machine use the up and down movement of wave to turn electricity generator. Dams are built across the mouth of the river. As water moves in and out of the river mouth, when the tide turns, the kinetic energy in the water is used to turn electricity generator. Hydroelectric power, HEP. Hydroelectric power schemes store water high up in dams. The water have gravitational potential energy, which is released when it falls. As the water rushes down through the pipe, this stored energy is transferred into kinetic energy, which turns electricity generator. And this is a diagram that will look at and describe how it works in our Zoom class. Geothermal. In some places, the rock underground are hot, so deep wells can be drilled and cold water pumped out. The water runs through the fracture in the rock and is heated up. This returns to the surface as hot water and steam, where its energy can be used to drive turbines and generate an electricity generators. This is the diagram of geothermal plant. Now, this question is meant for you to look at and answer it appropriately. I will also ask you to study the question very well and answer it appropriately. One of the questions has been done for you. So I need you to study the remaining question and answer it appropriately. In our Zoom class, we'll discuss it and I will call you one by one to tell me what your answer is. At this point in time, I want to say thank you for your attention. God bless you. And please remember, your CPT test is coming up next week. I need you to study your notebook, study your textbook, study the notes that will be uploaded on the internet. Thank you and God bless you.